All right, let's dive right into a huge question in AI today. Can an artificial intelligence actually learn to find and fix its own mistakes? We're going to look at a really cool research paper that's proposing a way to do just that, using a framework they call CRITIC.
I mean, think about it. We're already using AI for so much, from drafting emails to writing pretty complicated code, but we have all seen it get things wrong. So the real question is, can we actually build an AI that catches its own blunders before we do? Can we ever really trust it? Okay, so let's start with the heart of the problem, what we can call the trust deficit. You know, these large language models, or LLMs, they're incredibly powerful, but their unreliability is a major hurdle we've got to overcome.
And you've probably run into these issues yourself. These models can hallucinate, which means they just make stuff up that sounds completely convincing but is totally false. They can spit out code that looks perfect but is riddled with bugs. Sometimes they generate offensive or toxic content, and honestly, their behavior can be all over the place. That's the trust gap we're trying to close.
So what's the fix? Well, the researchers behind CRITIC didn't look for some hyper-complex new algorithm. Instead, they looked for inspiration in something we're all familiar with, how we as humans actually think and solve problems.
And here is the absolute key insight, pointed out right in the paper. When we're working on something tough, we don't just rely on what's in our heads, right? We use tools. We use them to double-check our work and make it better.
Just think about your own workflow. If you're writing a report, you're probably going to pop open a search engine to verify a fact. If you're working on a budget, you'll grab a calculator to make sure the math is right. We're constantly checking our own thinking with outside help. So why shouldn't an AI do the same thing?
And that simple idea brings us to the CRITC framework. It's designed to give LLMs that exact same human-like ability to use tools and, well, self-correct.
So CRITIC is basically a system that lets an LLM check its own answers using external tools. Then, and this is the important part, it uses what it finds to critique and improve its own work. It's all about interacting with the outside world.
This whole process, which you can see in this diagram from the paper, is a really simple but powerful loop. First, the AI verifies its answer with a tool, then it uses the feedback it gets to correct its answer. It's a verify then correct cycle that it can repeat over and over to make the output better and better.
Let's walk through that. First, the LLM gives an initial answer, same as always. But then CRITIC jumps in. It uses external tools, like a calculator or a search engine, to check that answer. Based on what the tools say, it generates a critique of its own work. And finally, it takes that critique and uses it to make a brand new, much better answer.
Okay, I know that sounds a little abstract, so let's make it concrete. We're going to walk through a simple math problem that the researchers used to test this whole system.
Okay, here's the setup. You've got 4 people, each with their own personal pizza that has 4 slices. Anne and Kate each eat 75% of their pizza. Bill and Dale each eat 50% of theirs. The question is, how many total pieces are left over?
So the LLM's first pass at this is not great. It writes some code to solve it, but the logic is wrong. It accidentally calculates the percentages based on the total number of slices for everybody, instead of for each person. The result? It says there are -4 pieces of pizza left, which, makes absolutely no sense.
And this is where CRITIC works its magic. This is the verify step in action. It uses a code interpreter and some basic common sense. It sees the negative number and immediately critiques itself, saying, hey, the answer has to be a positive number, so -4 is just not reasonable. It even figures out why it was wrong, noting that each person only eats from their own pizza. So, with that super specific critique in hand, the LLM rewrites its code. This time, it does the math correctly, calculating the pieces eaten for each person individually. It runs the new code, and voila, it gets the right answer, 4 pieces left. The verify then correct loop worked exactly as it was supposed to. Okay, so that's a really neat example. But does this thing actually work consistently? Is it reliable? Well, to find out, the researchers put it through a whole bunch of tough tests.
And let's start with a really big one, safety. When they tested CRITIC's ability to avoid generating toxic or harmful content, it lowered the probability of that happening by a staggering 79.2%.
That's a massive, massive improvement for making AI interactions safer for everyone.
Now check out this chart. It shows how CRIT stacks up against a standard method called chain of thought when answering really tricky questions. That F1 score is just a measure of accuracy. Higher is better. The standard method gets a score of about 64, but with CRIT, it jumps all the way up to almost 75. That's not a small bump. That's a huge leap in performance.
So we know that CRITIC works really well. But why? What's the secret ingredient here? Is it just the act of thinking about its answer twice, or is something else going on?
This is maybe the most important experiment in the whole paper. The researchers tested CRITIC with its tools, and then they tested it without them, forcing the LLM to just critique itself based on its own internal knowledge. And the results? They were like night and day. With the tools, performance went way up. Without them, the improvement was tiny, and sometimes the model actually got worse.
And this leads us to the paper's most critical conclusion, which is summed up perfectly by this quote. Just relying on an AI to correct itself without any outside feedback is a recipe for failure. The tools aren't just a nice feature. They are absolutely essential to the whole process.
Okay, so let's pull back for a second. What does all this really mean for the future of AI? What does it mean for this quest to build an AI that we can actually count on?
The paper's conclusion is crystal clear. An LLM just trying to correct itself in a vacuum is simply not reliable. The real breakthrough here is proving that when you give an AI the ability to use tools, to touch base with reality, it can finally start to bridge that trust gap. It's not about replacing the AI's brain, it's about grounding it. This feels like a huge step towards AI that isn't just powerful, but is also dependable.
And that leaves us with a really powerful thought to chew on. Criticism is about self-correction, sure, but the fundamental idea here, an AI using tools to learn and improve, is so much bigger. If an AI can learn to check its own math, what else can it learn to do?
And on that note, is your own thinking loop feeling a little stuck? Before you start hallucinating your own facts, maybe it's time for a vibe check. Go ahead and subscribe to VibeDoc for more explainers like this one, designed to help you self-correct your own assumptions and interact with some new ideas. Thanks for tuning in.